Welcome everyone. In our last video, we took a look at the idea of the difference quotient, and here we'll take a look at some of the results from that video. If you haven't seen that video, go ahead and take a look at that first and come back and watch these results. So let's consider again the average rate of change of f, which is the x squared function from 2 to 2 plus h, where h, again, is some small quantity larger than 1. We found in our last video when h, this small quantity, was equal to 0.1, we had an average rate of change of 4.1. And at 0.01, the average rate of change got smaller, went to 4.01. And I've calculated one more step in our table below. So let's just remember from our picture here, what are we creating with this average rate of change? The average rate of change between 2.21 and 2 is the secant line slope between those 2 points. In red, again, this would be called the secant line slope. And in this specific picture from 2 to 2.1, that secant line slope we found as 4.1. That would be the average rate of change between those 2 points. Notice as these 2 points are going to get closer and closer together as h goes to 0, notice that our average rate of change is getting smaller and smaller and converges, looks to be at 4. So we can write a statement that looks like this. As h goes to 0, or gets smaller and smaller and smaller, we could say that the average rate of change goes to 4. In other words, the secant line slope converges to 4 as h goes to 0. Now, what if h was exactly 0? Well, then we'd be sitting at a single point. Well, if we think about a slope at a single point, that would be considered as a tangent slope. So let's consider that on our picture. If we had a line that went through only a single point of our function, we'll call that this green line. This would be called the tangent line slope. Or the tangent line, and it would have slope here. Well, takes a look, it seems like maybe 4. As the secant line gets closer to this tangent line, that average rate of change, it gets closer to 4. So we could say in another phrase that the following is true. As h goes to 0, the secant line slope converges to the tangent line slope. And in this specific example, we could consider that the tangent line slope, and we can call that m sub t, based on our calculations, look to be approximately 4. Meaning that the instant rate of change at the point x equals 2 would be 4. So we could make a conclusion here. The instant rate of change at x equals 2 is 4. Again, because based on our calculation, we could feel pretty confident that that tangent line slope is going to be equal to 4, based on those secant line slopes as h goes to 0.